Hi everyone, welcome to the coding series. So till now what we have done is we have selected the LeetCode 75 as starting reference where we can go ahead and visit some of the data structure concepts as well as algorithms. I'm not sure whether we did any algorithms yet. CDP. Okay. I think it's mainly we have looked at some of the data structures. So you can see all the problems that we have solved so far in the series. But again, I want to emphasize that it is not about solving the problems, but rather to revisit the concepts and also to learn something new along the way. Maybe we learn something about the coding language that we used while solving the problem. We learned about recursion. Okay, we did learn about recursion, and then while actually solving the linked list question, so there was a scenario where we also learned a bit about debugging and so on. So today I want to try something different. So let's take up one of the data structures that we have already solved for. So that was the linked list. We did the reverse linked list problem earlier, and this was the solution where recursion was used. So today, let's not solve any problem, but rather look at the other three questions in linked list. So we won't be taking the same approach where we look at the brute force solution, then we see how we can optimize it, then we see what happens when we use different languages and what is the effect of the optimization of that language, and so on. But rather, I'm thinking let's look at the question and see the application of this question. Let's use ChatGPT. I've given a context to ChatGPT, and then let's see where we go from there. We learn data structures and algorithms, and we learn so many different concepts in computer science, but ultimately, it's also good to know, what are the implications of how these things are being used, right? So let's try to do that with like the three different problems we have, and we'll also see some common patterns. I have written something about the brute force and some basic stuff there. But anyway, let's see how this goes. So the first question I think I want to ask ChatGPT is, read through the maximum dim sum of linked list problem in LeetCode and LeetCode or any other place actually. The applications of the solution. So the thing is, we have not yet read the question right? So I think we should do that. So let's see what the question is all about. So in a linked list, so we have a nice visual example here of size n. This is of size 4. So n is even. Okay, so there is a 4, 4, 2. Okay. So the number of nodes is always even. The ith node, so they are going to use 0 index here. So this is called as a 0th, 1st, 2nd, and 3rd node. So the ith node here of the linked list is known as the twin of n minus 1 minus I. Basically, this is the twin of this one. This is a twin of this one. You can use this formula, or you can just create like a mirror in between and say they are twins of each other. Okay. And yeah, this is the derivation. We can all do that. But now let's see what the actual question is. So the twin sum is defined as the sum of the node and its twin. Okay, so this node has a value 5, this has a value 1. The twin sum will be 6, and the same for this one. Given the head of a linked list, so we have a reference to the head, which has even length, so we don't have to check for that, it is already there. So now we need to return the maximum twin sum. So one way to think about it is, we will, first of all, we will have to, you see this is a singly linked list, so we can only go one way. So there is a way to find a solution for this. I'm getting one way of doing it. Maybe you have a different way of doing it. Maybe I'll just quickly go over what's going on in my mind. Basically, let's say I'll store all the values in the list to an array. Store half of the values in the linked list to an array, and then for the next half of the values, go on adding it to the, okay, why is this, okay, there is something going on with this. Getting stuck. Okay, I readjusted the screen. So go on adding it to the already stored value, and then also check the max value at the same time, and then return the max value. So this is one solution that's currently coming to my mind. There can be different ways of doing it. I've not checked the optimized approach and so on. But the question now is, let's see, what is the application of the solution? So basically we saw what the problem is. We are given a singly linked list that is relevant because, there is only one way of going through it. And I said I'll store the values in an array. So what else are they doing here? There is a better approach, and the approach here is to use the slow and fast pointer technique. So this is a very interesting technique to traverse through the singly linked list, so that one moves at one step at a time while the other one moves at 2 steps at a time. So this will take some time to, let's say, understand. We can also go and ask ChatGPT about that. And then, okay. So basically the twin sum is computed. Okay, the list can also be restored. That's a good idea. Okay. So this is the slow and fast pointer technique, and the one I said was using arrays. This does not require as much space. Now, what is the application? So while the maximum twin sum problem itself, okay. All right, so the 2-pointer technique, yes, that is a very good point. So let's definitely go over the slow and fast pointer technique, which is called as the 2-pointer technique. And we can use that to find pairs, triplets that sum to a specific value. Interesting. Merging 2 sorted arrays. Is it searching for palindrome in strings or arrays? And memory optimization and linked list. Efficient ways to process linked list. Problem solving in interviews. Well, of course, that's not what we are interested in right now. Time complexity and space efficiency, optimal pairing problems. Okay. optimizing the pairing of elements. Interesting. So this looks like a wide variety of applications. Let's dive into it a bit. So in the sense, what is the slow and fast pointer technique? Let's ask. Give explanation about slow and fast pointer technique with illustration. I'm not sure if it's possible in the free version, but yeah, let's anyway go and ask. Awesome, that's good to see. So basically we have a linked list. Initially, we have 2 pointers which are pointing to the first node itself. Now the slower pointer is moving just to the next one, whereas the fast pointer is moving to the next one also. So it's already done 2 hops. Okay. Now in the second iteration, the slow pointer is at 3, but the fast pointer is at 5 because it goes 2 hops every time and so on. So let's use this example and use xcali_draw. Okay, I think it took an example which I already had, so let's take another example here. So now if I use this arrow mark, let's also increase the size here. So the slow pointer, I'll use the red arrow mark. So it is initially pointing here. Wow, that's too much. So let's reduce it. I think, yeah, that is still a lot. What about this stroke width? Okay, the opacity has to be high. I didn't read it properly. The stroke width has to be less. I think this is fine. Okay. So the slow pointer is pointing to this, and then the fast pointer is also pointing there. In the first jump, the slow pointer is going from here to the next one, and the fast pointer is just going one step. And now it is pointing to 2, whereas the slow one is pointing to 3. Now you might ask, so what is the big deal? Well, you have asked it to go and do 2 hops, and you have asked it to do 1 hop. So when we continue this process, that's when we will see what is the big deal about it. So then in the next iteration, it will go to 5, but this will just go to 3. Okay. Then this will go to 7, and where will this go? It will go to 4. And then this is reaching null. What does it mean if it reaches null? So, and let's see where this goes. So it's reached 5. So when the red one or the slow pointer is reaching null, it means it has reached the end of the singly linked list. Okay, that has reached the end of the singly linked list. There is no way of going back because this is the only reference we have in a singly linked list. Okay, but now where is this green pointer? If you look at this fast pointer, it is at 5, and 5 is nothing but the middle of the linked list, right? So if you look, there are 4 towards the side and there are 3 here. So basically, 4 and 5, this is even number of digits. So that's why you won't have an exact midpoint, right? But if you had odd number, this would be the midpoint. So if this moves at twice the speed of this, that means when it reaches the end, this basically reaches the middle. Now that's where we can see how that is helpful in this maximum twin sum problem, right? Now in a singly linked list, I did 2 runs, you see, and no, I just used an array. But let's say you want to have mirror image, right, to do the sum. So when the first pointer has reached till here, the second pointer has then gone to the next value, which needs to be added back, right? So that's where it feels like, okay, with the mirror image like scenario where we are reaching the middle and then we are doing some processing, intuitively we can say that it does make sense to have this approach, right? We need to have two windows here, so let's go back. So that was very interesting to see. Now, finding the middle of the linked list, that is a very straightforward use of this approach. Also, another thing you see is I used an array which required extra space, and this is where that requirement is not there anymore. Well, for this one, I would not say that yet because it requires something else. But anyway, so finding the middle of the linked list, that's a very interesting thing to note. Detecting cycles. How can we detect cycles using this? So if you look at this, at the 4 is again pointing back to 2, right? So what would happen is, think about, let's do that. Let's take this, let's copy this. I can't copy that, okay. Let's copy paste, and then I will make 4 point back, let's use black, and then I'll just make it point back to 2. So now, what will the slow pointer do? It was at 1. The green one was here. Then the slow one will go to 3. This one will go to 2. Then the slow one will go to 4 and back to 2 because of this arrow mark. And you see, they both are meeting here. Now that is already a red flag, right? So there is no way this fast pointer will meet the slow pointer. And that's why, oh, I'm sorry. Am I saying, this is the fast pointer, right? This is going faster than this. I'm sorry. I think I said the other way around. So basically one pointer cannot meet the other one, but in this case it is meeting. So that means we detected a cycle. So that is interesting to know. Anyway, the application of fast and slow pointer, one more thing what I want to ask is, what are the real world applications of the above 4 points basically? This is very interesting. So the problem with trying to understand these is we need to know something about distributed system. We need to know something about memory management. So let me refine this question. So what are the real world applications of the above 4 points? Explain to a layman. Stay louder. Okay, so what it is saying is finding the middle of the linked list. How is that going to help when you're dividing a big project into smaller parts? Finding the middle helps you balance the workload. Okay, that is true. I have another question for it. So, for 1, right? If you want to find the middle value, it would have been easier to do so using arrays. Why would someone store it in linked list? Well, let's see if it can answer such layman questions. So why use linked list instead of array? That was the question mainly. So one was dynamic size. So in arrays, there is a way to resizing the array in an efficient way, and that requires some extra work. Whereas for linked list, you just have to create one new node, add it, delete a node, and so those aspects are easier. That is true. Memory efficiency. Now this is again related to the resizing aspect of array. That is so true. That is also true. So you don't use the array for making a tree structure, right? We don't use an array, interestingly, in these scenarios. Don't you think this is very interesting to know? So you're learning about linked list, you're breaking your head on how to solve this problem, what is the efficient way to do it, and so on. But then you see, there is a reason why this is all there. And now you have ChatGPT and other AI tools to ask these questions. So you don't have to worry about, okay, why am I even doing this, right? Hopefully this exploration was not too boring, and it gave you some ideas on how you can go about figuring out the application. So we were not able to get to the other two questions, but I think this itself gave us a clue about, okay, why do we have linked lists, right? And not arrays only. So there is a purpose for every data structure. We also learned about the slow and fast pointer technique to find the midpoint of the array, and how that can be used for different applications. Now the slow and fast pointers, you see, like the fast pointer and the slow pointer can move at different speeds to achieve different things, right? They don't have to move just one hop and two hop. So it could be that the fast pointer will move at 4 hops and the slow pointer will move at 2 hops. Why not, right? For your application, different movements might make more sense too, right? So that's one more thing we learned. So even having this twin sum problem, there is an optimal, to find some optimal results. I think something like that. It was helpful. I don't remember exactly. Optimal pairing problems. That's where it was helpful. And that looked like such a general, it was applicable to a lot of different things here. So that was good to know. It was space efficient. We didn't require extra arrays or variables or something else to do the processing. We just needed 2 pointers, right? Which was very less space requirement. So those are some helpful things to know. Hopefully, next time when we try to really solve these questions, this might sound more interesting. Hope you had some fun. Thank you. See you in the next episode.